So now, after all that introduction, we begin the first regular class. This one is on project management, and this one is going to cover two key skills. And these skills, some of the things we're going to do have easy learning curves. Some have steeper learning curves. Some will take longer to master. This week is two primary tasks. One is distributed version control, and one is web development. So each week at the end is an assignment, and sometimes they're just individual, sometimes there's group assignments. And then I link featured assignments. This one, well, first, the assignment is you're going to download, read, and sign the student agreement, which I'll explain shortly. You're going to read a Git tutorial, which I'll explain, and then you're going to start your personal site. Then make a note on that. So the three featured assignments I've linked all have to do with their examples of websites, but in particular, lessons from the Fab Academy. So this one was from a really interesting student you'll learn about, and she describes what it was like to be in the Fab Academy and how she did it. And so I recommend this as a nice intro. This is another good site. This is full of tips and tricks on how to survive the Fab Academy. This was Elena in Leon. And each of you, you'll build a site that describes you. You're going to link your weekly assignments. You'll document the final project. And again, I particularly linked, she has a bunch of good tips on what you need to do to survive the Fab Academy. And the third one, again, is this was a student on tips and tricks and lessons on surviving. So we don't give you a standard learning management system. We just give you a web server, and you're going to build a website. That means there's more to learn, but it means you're not limited to a learning management system. You learn the skills of web development, and there's much more opportunity to be expressive, to convey who you are. And so the sites are very different because you're all very different. So first, synchronization is a task where if you have files on one computer, you want to get them on another one. And so to do the work in the class, you'll be working in your lab locally, but you need to get the files on the central server we're running. And so if we go back to the Fab Academy site, now each of you has a starter website that you're going to start filling in. So what file synchronization does is what the name says. It synchronizes files between two locations. And so I make a lot of use of rsync that does it very efficiently for backups. So you could have a terabyte of data on your computer. You could have a server you use for backups or for publication. And then if you change one line in one file, you don't want to have to send a terabyte each time. You only want to send the change. So that's what rsync does. It very efficiently calculates changes and just sends the updates. We won't be using that. We'll be using Git, which I'll explain next. But if all you want to do is mirror and synchronize files, rsync is a great way to do that. And I use that all of the time for backups. And so you can back up between computers to the cloud, to a hard drive. Very handy for that. Version control does something much more. And so I've listed a number of versions of version control. Yeah, I'll talk about Google Drive and Dropbox. Uh, Git is under the hood, the heart of what things like Google Drive and Dropbox use. So there are a number of these. Git pretty much has one. Git came from Linus Torvalds, who's behind Linux, and in British slang, a Git is an annoying person, and he embraces that he's an annoying person. That's really the origin of the name. What Git does is deceptively profound. It does many things. So to start, there's a file system, and you're used to using a file system and seeing your files. But what Git maintains is not just the current state of the files, but the history. And so you do what are called commits, where you take a snapshot, you take a picture of the files. And so as you're working, you'll be like developing code or developing your website. And as you progress, you might be testing versions in different programming languages, or you might have versions of the website in different languages or using different tools. So at any one time, you see your files, but Git is maintaining the history of the files. In addition, it can maintain multiple completely separate versions. You can have what are called branches, where you have versions in different languages. You can have a production version, you can have a testing version. And then what Git lets you do is what's called pushing and pulling. So you can have all of this on a server. You can pull it onto your local computer, work, and then push it back to the server. But in addition, you can push and pull to other places. So like, on my phone, I run Git, and I have a few different, a repository is this thing I'm describing that's the files and everything that goes with it. And so when I leave home in the morning, I don't just have my work in the cloud. I pull onto my phone a repository that has everything I'm working on. Then I can work on it on my phone. And then at the end of the day, I push it back onto a server. And then if you need to move it between computers, you can push and pull onto a memory stick. You can push and pull between computers. You can do it with somebody you're collaborating. And so Git keeps track of all these different versions, make sure that they stay synchronized, and it can also identify where there's conflicts. And so you'll be using Git to push your work onto our server to publish your web pages, and you'll be using it to manage your development. So Git is very well documented. This link, I'm going to go through more detail at the end of class, but let me start at the beginning. When you go to Fab Academy 2026, this is a web server, and each student has a website that you'll be filling in. All that is running on GitLab. GitLab is a platform to serve Git repositories. And so if we go to GitLab, then this is, for example, the class site. These are the files on the server, but from here I can go into this shows the history of all the different people working on the class site developing it. And then you can drill in. Each of these is a commit that does one operation. Ellie, question?
Do we need to pay when we're gonna use GitLab? to have an
So
account?
it's a good question. So many of these services are what's called freemium, meaning GitLab. So GitHub you may have heard of, um, is a service bought by Microsoft. GitLab runs a service where you can run on their GitLab, but the underlying platform is open source. So we run our own GitLab instance. So part of the tuition cost of Fab Academy helps pay for the servers and for Julian, who maintains it, but the platform itself is open source. You can even run your own GitLab.
Okay.
So, yep. So GitLab maintains the repositories, and then it does a bunch of other things. It provides a web interface so you can edit through the cloud. And I'm going to come back and talk more. So I know my pointer's not visible. I'm going to check the pointer after class. Um, GitLab also allows you to track issues, and it does a bunch of other project management tools I'll talk a little bit about. Git has a really good tutorial. And so these concepts of branching, merging, committing, cloning won't make sense until you go through it. So one of the jobs for this week is to go through a Git tutorial. And there's a bunch of fun things people have done. So Dang Git is a nice page on how to deal with headaches with Git. Um, this is another page talking about what's missing. These are all just fun things you can read to learn about it. And so you can get Git directly from Git. It's an open source project. Um, on a Mac, you can install it with Homebrew. Um, in Windows, there are multiple ways to do it. You can just stay in Windows and use what's called Git Bash and install that. You can use what's called Cygwin, which is a compatibility layer. What I recommend is this, which is the because so much developer work is done in Linux, Microsoft has embraced it. So Windows subsystem for Linux builds a whole Linux installation into Windows. And so that's actually the easiest way to do it. I generally use Linux. And so typically I use the Ubuntu version of Linux. Um, Termux is a tool that lets you do all of this on a phone in Android. And this is a tool that lets you do it in iOS. So one of the things you'll need to do initially is you can do all of this through the web interface on GitLab. But as we progress, one of the skills is to learn how to take your work in the cloud, pull it onto a local computer, work in your local computer, and then push it back. I'm going to come back towards the end of class and finish going through this file with lots on how to do that. Dropbox does this under the hood as a cloud service that's commercial. OwnCloud is an open version of that. We're focusing on Git because it's more convenient to have this so you don't have to think about it in the cloud service. But as you become a developer of hardware, software, web, these skills are really important. Learning to manage repos for distributed version control is a key development skill. And that's why we want to focus on you learning to use it. So you'll be using Git to manage the files. Then you're going to be building a website. And so in each class, I'm not going to tell you the way to do something. I'm going to give you many options. And I'm also going to give you alternatives with both commercial and open source tools. So you're going to build a website. To serve web pages, Apache and Nginx are among the most popular common web servers. What those do is when you go to the Fab Academy pages, all of this is being served through GitLab by Nginx. So you can install that. These are open source. You can install it and run it locally. Typically, that doesn't make sense. It only makes sense on a bigger server. A web browser can open a file. So if you're working on a web page, you can just open it in a web browser. And then these two commands will be very handy. We're going to be using a number of programming languages and programming tools. One is Python, and one is JavaScript. So when you install Python or install JavaScript, which I'll talk much more about, these are handy commands that start up a local web server. So the idea is for this week's assignment, and after this week, your website won't be done. It'll just be started. Each week, you'll be improving your website. While you're developing, you need to view the website. And so you can install Python and then run this command, and then you'll have a web server running locally to test your website, and then you can push it off to the server. So how do you make a web page? W3C is the standards bodies for the web. HTML is the language we use to put things on the web. Developer.mozilla.org. Mozilla is behind Firefox, the browser I'm using. They maintain a really nice set of references. CSS is something you use to style web pages, which I'll say more about. HTML5 adds video and audio, a number of features to the web that we'll be using. And there are a lot of different sites. This is one that offer templates. So we've given you a starting template. But as you progress, you don't have to use our template. You can use another one that does whatever you want. We've had all sorts of, let's see, let me find, from the fall class I took at MIT. So yeah, this was a fun one. Haley used a template where her website turned into like Microsoft Windows 3, and you can actually use all of these tools to navigate and open windows, and her whole website is an interactive historical Windows desktop. And that was all not running in the server, that was running in the browser. So once again, you all have starting pages. And so initially, you just need to learn to edit this page. But as you progress, you don't need to use our template. You can use whatever you want. A really good skill is web browsers let you view source. So I just opened the source. You're looking at this page. Here's the HTML commands. My web pages, you could call them, there's different stages in the life of the web. My web page I'm showing you dates back to the earliest days of the web. This is Web 1.0. It's simply a page of links. Initially, I did that because these pages date back to early days of the web, but I've kept this because this is a very simple, spare, easy to navigate interface that stands the test of time. There'll be all sorts of modern content linked from the pages, but what I'm writing are these really simple indices. So what I do is I actually write the web codes by hand. And so this says it's an HTML page. This says what font I want. Then here we are in the web development section. I want it to be bold. And then these are hyperlinks. These are links to addresses. And so it's really quick and easy to just write these codes directly. So the lowest level you can do is learn the HTML codes and write them. And to do that, I just use a text editor. And so VI is decades old. It's about 50 years old. It's a simple text editor that's fairly religious among programmers. And that's because it dates to before there were Windows and mice. And the reason that matters is when you're using VI, you don't have to keep reaching for your mouse. Your hands stay on the keyboard, and you can do all the skills of navigating open pages, moving through it, saving, without ever having to reach for a mouse and click. And so that's why it's so beloved. So for simple web development, I write HTML codes in VI. Now, one step above that is these are all integrated development environments. So VS Code is a very powerful open environment, and you customize it for tasks. So you can use it for writing application software. You can use it for writing embedded code, all things we'll be doing. You can use it for web development. And so these are, compared to the simple text editor, these give you context help, and they reformat, and they give you a number of tools to help with the web development. Okay. Then going further away, LibreOffice, yeah, and then I should link, there's a note in the chat. I should link it. VS Code isn't complete. It's free to install, but it's not completely open. VS Codium is the complete open source. David is asking about packages on the web server. We locked down the web server for stability and security to just basic web serving. So anything non-trivial you need, like JavaScript extensions, needs to run client side. You can check with Julian on services on the server, but we have that fairly locked down for stability and security. So yeah, but I'll link VS Codium. LibreOffice is a freely available open source cross-platform office suite. And it includes a WYSIWYG. What you see is what you get web interface. So you can open, so, let's see. Here I'm typing these codes, and then I have to look to see what the web page looks like. WYSIWYG is where you just pick fonts and formatting, and you're typing the final web page, and that's how it looks. That's good because you don't have to separate the codes from the presentation. What's bad about it is the actual HTML these WYSIWYG tools write is typically fairly ugly. It's hard to edit. So if you start in a WYSIWYG tool, you need to stay in the WYSIWYG tool, and it might limit what you can do. Dreamweaver is a commercial version. LibreOffice and SeaMonkey are open source versions. So these let you build web pages without ever learning an HTML code, just doing it in a graphic environment. And so you can do that, and they're popular. I recommend starting at a lower level, learning the codes, then progress to using a higher level tool, but understanding what's under the hood below it. So then JavaScript is what was running in Haley's page. The page was suddenly acting like a Windows desktop. JavaScript is a scripting language for the web. And a huge amount of work has gone into its performance. And so JavaScript is how you build interactivity into your web pages. Later, much later, in the interface and application class, I'm going to talk about how you build user interfaces, how you do graphics, how you play audio, how you play video, all of those things in web pages. One of the tools you can use is jQuery, which gives you what are called widgets. Widgets are things like buttons and sliders and dialog boxes. So you don't make the web page in JavaScript. You can, but it's awkward. You make the basic web page, and then you use JavaScript to build the interactivity. And I'll be using that in a number of weekly examples, and we'll spend more on that in the programming class. So then, let's see. Yeah, I'm not talking about Wasm here, but Wasm is WebAssembly, and what it lets you do is compile other languages so they run in the browser. And we will be using that later in the cycle. So Markdown was developed. In HTML, you have to learn all of these codes. Markdown is human readable, so you can read it just as text, but it turns into HTML. So like a pound sign is for a heading, and a star is for an asterisk, and a break is for a web link. So Markdown is a kind of easy to write, easy to remember notation that gets turned into HTML, but is easier to read. And then these are all frameworks you can use to build websites in Markdown. So rather than writing HTML codes, you build Markdown sites, and then they get served as HTML. So we support mkdocs. That's an option you can use to build your site. We don't start you with it, because once again, we want you to start by learning the basic HTML. But as you progress, you can migrate your site into from basic HTML to use Markdown to make your site. Now, to do that, what's called CI/CD is a core thing that GitLab does, and it gets implemented with what's called YAML, and all of those acronyms have to do with production workflows. So when you push your work to the server needs to publish it. If it's in mkdocs, it needs to turn it into HTML, and however it gets there, it needs to get to the right place on the server. And so CI/CD and YAML are the mechanics of how the server builds the workflow. And you don't need to know about that at this stage. Julian has configured that. But in the future, you might, for example, have a new website, and you push the website. It has to go through testing. It has to get served. It has to be cached and backed up. And all of that gets implemented with CI/CD and YAML. And that's one of the core things that GitLab does. Then there are a number of things we're not supporting. And coming back to the question, so we're not installing Docker images. So GitLab supports Docker images. We're not supporting it for the class. There's things like CGI, PHP. All of these introduce either security vulnerabilities or stability and scaling issues that we don't support for the class. In the end, you produce HTML, and that's what we serve. You can use a number of workflows to produce it locally, and then the interactivity happens in the browser. So for stability, scalability, we have the server locked down to just those basic skills. So initially, all you need to do is log into GitLab, and using its web interface. Well, here, let me demonstrate. This is in GitLab, the 2026. This is the website. And so in here, I could go to the schedule. This is the schedule. I usually don't edit it here. I edit it locally on a local computer. But from here, I can open up an editor. And it's very similar to VS Code interface. So it's just getting that loaded. And now in this, yeah, we're now in class. So I'm just going to say, hello world. And I'll put in an HTML break. Now I'm going to commit that. So I just committed that. And then what that triggered is a pipeline. And so right now, um, uh, the pipeline is running to publish my site. And that just finished. And then it takes a little while to appear. Um, but it'll appear in a little. Okay, and so now on the schedule, I just added hello world. So all of that was using the web interface to edit the website. And from the web interface, if we go back there, um, you can upload files, create directories, and do all of those services. So initially, as a beginner, you'll start building your website that way. But then as you progress, you should grow beyond the server and learn how to work locally. Bobkin's asking about Docker and Kubernetes. All of those questions you're asking have to do with what we're going to be doing much later when I talk about application programming. There, I'll talk about um, these have to do with how you deploy at scale in the cloud. Right now, we're just building a web page. We don't need to cover all of those things. I'll talk about containers in the future when we get to the application programming. But you don't need to know about containers to build websites. And once again, remember that you have help in your local lab in everything I'm covering, and there's the help sessions with the global open time. So to start, you'll do the Git tutorial, browse through the HTML documentation. It's very well documented through the Mozilla platform. Then start with the web interface, but learn about these local interfaces, and you'll start building your website. At the end of this week's assignment, it'll just barely be coming to life. All I want you to do is be able to edit your website. And then each week you'll be refining and improving your website. This next group has to do with content management systems. So something like Canvas is the learning management system, LMS, that MIT uses for its classes. Early on, we used to use this for Fab Academy. And the reason we dropped it for two reasons. One is the skill is just to use a learning management system. It doesn't help you start a business or run a Fab lab. And the other is you have to fit what you do into its format. There isn't room to customize it for how you're expressive. And so that's why I link these for background, but you're going to actually just build your own website. Then to collaborate, Slack, you're probably familiar with, is a tool for collaboration. Mattermost is a open source tool that's similar to Slack, and it's linked to GitLab. So I'm going to log into the Fab Cloud Mattermost. And so in here, let's see, This is a chat for 2026 Fab Academy. And so one of the ways we'll be communicating is by using the chat in Mattermost. And then another way we'll be communicating, if we go back to the class, is the issue trackers. So Mattermost is good for a conversation. If you have a specific issue, like a problem to fix, the issue trackers let you post and respond to issues. So I'm going to start an issue. This is a test. So I just posted an issue, and issues can have people they're assigned to. They can have deadlines for scheduling. They can link to content. So these are tools we'll be using to communicate and collaborate. Let's see. There's a link to Meme Academy in Mattermost. There's a lot of meme generation. You'll see a lot of traffic there. Okay, then we used to have to teach this part. We don't really anymore. For video conferencing, WebRTC lets you do video in a browser. And so WebRTC is at heart what it made possible to just click and join a video conference. Previously, you had to learn a lot about the protocols. But the two parts you should know about, one is something like Zoom is a paid commercial service. Jitsi is an open source tool that lets you run your own server. It doesn't work on the scale of a meeting like this with hundreds of people, but for tens of people, you can run your own Jitsi server. And then OBS Studio is a really handy thing to learn about. It turns your computer into a production studio. So right now you have a webcam and a microphone and you're sending your audio and video. With OBS, what it lets you do is you can choose multiple sources as the source. So you can have a camera looking at a project and a camera looking at you, and you can have audio from the computer, and you can mix and pan and merge. And so it's a really nice tool to turn your computer into a production studio. Adrian? You had a hand raised, Adrian? I'll go on. So then, let's see, remote desktop we don't need yet. The next set of tools are, these are all versions of tools that let you make something that looks like this. They let you keep track of tasks and follow their progress. A bunch of different versions that all let you do that. And each week you're going to need to manage time, and then it's going to get worse when you work up to the final project as you run out of time. And so initially you won't need these tools, but if you look at some of the really nice final projects of like the delivery robot or the solar tracker, it had a lot of different components and subsystems and dependencies. And so to finish that on time, as it gets more complex, you need a tool to manage all of that. So now I'm going to talk about some basic project management principles. These are all going to sound probably obvious, but all of these have been a source of billions of dollars of failures. So the first one is what's called the 80-20 principle, and it's really the 95-5 principle. And what it is 80% of the tasks take 20% of the time, and 20% of the tasks take 80% of the time. So like when you build a house, it's great. The framing goes up quickly, but like finishing the wallpaper and the wiring, you can run into all kinds of problems, and what looks like a little task at the end ends up taking all of the time. So you might be making great progress on your final project, and there's just at the very end, you have a bunch of separate things working, and you just need to plug them together. And the little bit at the end of plugging them together, it turns out takes almost all of the time. So 80-20, and again, it's more like 95 and 5 is a lot of the things that look hard you'll zip through, and things that seem like a little detail at the end up expanding to being the source of the failure in much of the time. Something you'll hear over and over from me is demand versus supply side time. So uh, demand side time is you do a task, then you do a task, then you do a task, then you do a task. But the problem is if it was due here, you failed. Supply side time is in advance, you make a map of the time you have and you figure out how you're going to use it. And it's a very different way of working. So after today's class, you can start reading Git, you can start web development. But what you should do is realize a week from now, you need a website. So you can afford one day on Git, one day on HTML codes, one day on choosing an editor, one day to prototype the site, one day to refine the site. You make a schedule in advance, and to a surprising extent, you can learn to work to that. So you need to work to the schedule of the time, not work to the task. And you fit the task into the time. Now, to do that, you have to do triage. So when an airplane crashes and first responders come, if somebody died, you can't help them. If they're up and walking, they may be bleeding, but they're probably okay. You need to figure out who you can't help, figure out who you can ignore, and focus in on where help will make a difference. So each week, you're going to be doing triage. You'll have a big vision, and you might fail to accomplish it. And you need to figure out what tasks to save and what ones to give up on. Likewise, if you do task, 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 if one task fails, it blocks all of them. So the charts I showed you show tasks running in parallel rather than in series. So one task can't block all of them. Karen is asking about how to teach project management. Karen, the best way I know is to do it. So we're going to be doing project management each week. We're going to be doing it in group projects. We'll be doing it in the final project, is to experience it. So a big one you'll get tired of hearing me talk about is spiral development. Linear development is you start here, you work to the end, and then you're done. And there have been large government projects where you spend 10 years and $1 billion and it doesn't work. Spiral development is you work in loops. So let's say you want to make a delivery robot. The first version might just be a cardboard prototype. And so you make a full size, a little version of the robot out of cardboard to see how it looks. The next version is you make a full size one in cardboard, but there's a finished robot. The next one is you make it in a finished material. Then you add motors, so it's moving, but the motors are pre-programmed. Then you add a programming interface, so the motors can be programming. Then the battery, it had a tether, so the next one is you add a battery. But the idea is each spiral ends up with a complete finished something. And then each spiral adds more to it, but you continually are able to test it. So I'll be stressing working in spirals rather than in series. You're going to be doing a lot of debugging, and you're going to make things that don't work. You can debug from the top down by simplifying until it works, or you can debug from the bottom up by adding things that work until it stops working. To do that, it's going to be really important to build hierarchy and modularity. So instead of one big system, your system have submodules that you can test separately. You heard the puppet in the beginning talking about documentation. Each week, you're going to run out of time. So the only way to keep up is to document as you work. You won't be able to finish, then document. You need to learn to document as you work. Likewise, your labs can easily become a mess. It doesn't work if you work and clean up later. The only way your lab will survive is if cleaning up is part of the working cycle. So every work session is also a cleaning session. Otherwise, your labs get trashed. Don't you have instructors, you have the help time. Don't use them as a crutch to not do your own work reading the manual. So there's going to be all sorts of documentation. Today it's for Git and for the web. Next week it's going to be for the design tools. Use the documentation and use the help for the limits. Don't use it as a crutch. This is a really lovely book on project management that I recommend that has a lot of great insights into these underlying skills of project management. So all of these sound kind of obvious. Every one of these has been the source of major failures. And every one of these are skills you'll need to master to get through each week's assignment. So now let's go back to a few things. On the 2026 site, in documents, there's a document for labs, instructors, and students. So the Fab Academy will teach digital fabrication. We're going to pull together lectures. We'll give you feedback. We'll document your work. We'll provide the staff local tools in the lab, the central infrastructure to teach it. We'll manage the finances, share that, publicize it. Crucially, we're responsible for a respectful environment, diverse community. You as a student, you need to come to class, obviously. It doesn't work if you don't come. You have to document your work. And the way to understand the documentation is you need to have enough information for somebody to reproduce your work. So that's the threshold. You need to show enough. So you need to link your files. You need to explain your work so somebody can reproduce it. You're going to learn from web pages of your predecessors, and you're going to build web pages that'll help your successors. You need, obviously, to honestly report your work. Occasionally, we've had plagiarism. And then a big one in the current era is you can use AI tools to do many of the assignments, and that's fine. But it's plagiarism if you don't give the prompts and the AI tool you're using. So if you just ask ChatGPT to build your website for this week, you can tell ChatGPT, give me a website. That's okay, but you need to tell you use ChatGPT and you need to post the prompt you used. It has to be enough to document your work. During each week, we'll be doing a random review where I'll be asking you about what you did, and your instructors will. We'll be sharing your work with the Fab Academy in the ways I've been doing. You're going to be hearing a lot about safety in your labs. Initially, the only danger in this week's assignment is to your brain if this is difficult to learn, or to the server if you upload things that cause trouble, which I'll talk about in a minute. but eventually we'll be dealing with physically dangerous tools. You need to leave workspaces clean and help keep your lab clean, cover the costs to support you. Um, uh, you need to recognize there's limits on time in the lab and staff. That you can't show up late Tuesday or early Wednesday just before class and panic and expect everybody to drop and support you. You need to fit into their schedule. And you need to be respectful to your peers in your lab environment. And that sounds obvious, but occasionally we have people with unreasonable demands and unreasonable behavior in the lab. So what you're going to do is take this file, edit it to add your name, and then commit it to your repository. So once you've learned Git, you'll learn how to commit a file in the repo. And by doing that, you'll sign the student agreement. Okay. So now let me go back. This page initially has links on Git. Then I have a list of mistakes you're likely to make. And the most important mistake is you heard the puppet talking about PNGs. What that was about is each of you is going to build a repository. And if we want on the order of a gigabyte per person per semester, and we have 20 or so topics, it means you can generate tens of megabytes per topic per week. An uncompressed image from a high resolution camera can be a gigabyte. Yeah, a single picture could add up to the size of all of your work in the whole semester. And so we'll talk more about this in next week's class. Images should be at resolution to see on a web page and should be compressed, which JPEG does. PNGs can be 100 times bigger than a JPEG. We use them when you need uncompressed images for engineering, but just for documenting a picture, it's wasting a factor of 100 in size. And the same thing will be true about videos. And so I'll be talking about image and video compression in the design class next week. So these are common mistakes you'll make. This talks about what you need to do to get set up to do Git locally. And this won't make sense just staring at it, but in your lab, your instructor can help you understand it. And then each week we have, not each week, every other week typically, we have a recitation. So the recitations are Mondays at 9 o'clock Eastern Time. And the recitation on Monday is going to be Julian helping you understand version control, understand everything I've covered. Finally, you can do Git with a graphical interface where you click and drag, but the more expert you get, the more you do it just by typing commands in a terminal. So when I want to commit my work, I don't open a GUI and click and drag. I just type a short command that commits and pushes my work. And so these are a bunch of different terminal commands that you'll learn. And in fact, I do this so often, I define shortcuts for them. And so you won't need this right away, but as you progress, here are lots of Git commands. So now finally, we're up to, I want you to build a personal site that describes you and a final project. Your final project may change, but let's see, if we go back to, let's see, we had people, I had shown you, Haley had this fun site. And then here in this unusual interface is this tells you about her, who she is and what she's doing. So once you get going with Git and get going with HTML, start your website. And now if you go to the class page, you'll see a search engine down here. So if you want to make a drone, you can learn about projects that made drones. Here, I'm just guessing. If you like pizza, we can search about projects that did something with pizza. So there's a search engine here that can let you browse through projects to get ideas. And this week, you're going to, let's see, Luke is noting pancakes. We've had many pancake projects. So make a description of a final project. Your final project may evolve, but make a description. Then next week's class is going to be on design tools. You're going to learn about 2D and 3D design. And next week's class is you're going to do basic rendering of the final project. The final project, you're not stuck to what you do this week. It can change through the semester, but I want you to describe a starting project this week to get you thinking about the final project. As we progress, one way to do the class is do each week's assignment differently and do the final project at the end. It's better if you can organize it to use each week to move towards the final project. So in computer-controlled machining, the assignment is to make something big. You make something big that supports the final project. Let's see, there's a question about, so lots of, Roberto's noting about AI. We've had, as an experiment, AI students do the Fab Academy, and the AI student today can do about half of the Fab Academy, and it needs a human to do the rest. And quite seriously, as this emerges, it becomes a hybrid where you can use AI tools to help you do the work in the Fab Academy, but crucially, you have a central role in helping to steer it. And again, in using AI tools, you need to document it. So all this stuff about compressing images and videos we'll do at length in next week's class. For now, just get started. So once again, let me recap schedule. Make a schedule for the week. This weekend is the open time. Adrian, again, what time is that? Pablo, Rico?
Yeah, sorry, we are discussing here something. Sorry, could you repeat, Neil? Sorry.
Yeah. Just
to the global open time. I put the link in the chat. There is at 10 a.m. Boston time in the Saturdays, 1 hour, and and we are everybody's coming.
And the instructors.
So great group of wizards available to help you. Hiroi is noting in the chat the assessment will help you understand what we're looking for each week. Then Monday, 9 o'clock, Julian will do a whole recitation session. These are an hour long on version control. And finally, you have your experts in the lab to help you. And then next week, we'll start up the random generator. The random generator will pick people in random order, and we'll meet you. We'll learn about who you are. We'll discuss what you did in the weekly assignment, and then we'll discuss your final project. And we do that for an hour or so. And then towards the end of that session, we just have an open time where people can volunteer problems they had or successes they had. And then we'll pick up with the design class next week. Okay, so that is the launch of the Fab Academy. Keep coming back to what I said early on, which is keep track of three things. Each week, you're learning what is the space. So now I've introduced levels of making web pages and tools for version control. So you should have some sense of what that's about. then each week I expect you to do a basic task. So at the end of this week, you have work committed with a starting web page. And then I pointed you to where to learn more. I pointed into all the documentation on Git and HTML. And as we progress, you'll get better and better at it. You're not meant to be an expert after 1 week. Let's see, wrapping up on the chat, Tom, Tom, if Cooper finishes, clearly showing it meets the standards, that's fine. What Cooper presented wasn't enough to evaluate. Did he meet the standards?
Okay, but can we just send it to you now? He doesn't have to wait till June to re-present.
Oh, sure. No, it doesn't. Yeah, you can send me where there's an update. Yeah, and review it with the global instructor to make sure the global instructor signs off. It doesn't have to wait for the next cycle.
Well done. All right, excellent. All right, thanks.
Okay, so this is going to be challenging, and this wasn't designed to be a life transformative experience, but a surprising number of students described this as a life transforming experience. So we're off on a big journey. And so I look forward to seeing what you accomplish, and I look forward to hopefully meeting as many of you as I can in person at the graduation. And with that, our first class is done. Oh, and a fun tradition is at the end of class, we all say goodbye. Everybody unmutes and you say goodbye in your native language. So goodbye.
Goodbye.
Adiós, buen día.
Пока, до свидания. Grazie, Gian. Ciao,
Bye-bye.
ciao.